Okay, so here's a video, part 2 on lesson 38, which is the definition of a parabola. I'll flip you through the notes real quick if I still have them. Then I'll go into a question. The question that I'm going to do, the example is going to be question number 13. So the first question is, what does a y equals line look like, and what changes about the problem when the directrix is a y equals line instead of the x-axis? So those notes were... Oh, and here's the notes from yesterday in case you missed it, didn't catch it in my previous video. These were the steps and all that from day prior. Oh, it seems I've erased the notes. Oh well, no big. I'll answer them. Okay, so a y equals line is horizontal, meaning sideways. And what changes about the problem when the directrix is a y equals line? We end up with the distance formula still, so like we end up with the square root of whatever, but it's not equal to y. It's equal to something different now. So let me show you an example, and then I'll explain what the rules are. You could just skip to the end of the question if all you're looking for is the rules. Now, question 13 says, derive the analytic equation of a parabola. Okay, so find the equation, given the focus of 0, 5, and a directrix of y equals 1. So I'm going to draw a graph. Oh, they were up here. Okay. So I'm going to draw a graph. Follow the same exact steps that I have on the previous lessons video. So if you didn't watch that, you might want to jump back and do that first. I draw my axes. That's my first step. That's my y-axis. There's my x-axis. I put the arrows onto the end because I'm a stickler for details. Now I need to put the point. The point from question 13 is 0, 5. It doesn't matter if this is perfect because the idea is just to get a picture of it. So this is 0, 5. Now that's 0, 5, and the directrix, it says, that's my next step to draw that on. My directrix is y equals 1. Now I'm going to follow the same steps, start in the middle, draw a parabola, place a point on that parabola, and I'm going to call that point x, y. Now I have two distances that by the definition of a parabola are equal. It's this distance from point to point, and this distance from point to directrix. Those need to be equal, so I can mark them up like this if I want. Now what's the formula for each of them? Now this right here, from point to point, is always going to be the distance formula. And the vertical is not going to be y this time. It's not going to be y. Last time it was y, this time it's a little different because the directrix is different. Now let me explain to you why and how you can figure out what it is. Think about when you're plotting a point. If I was plotting a point, right, like x, y, or if I was plotting a different point, like let me give you an easier example. If I had an x and y axis, and I wanted to plot the point 3, 5. What would you do? I would count over 3. I'd go, all right, 1, 2, 3. And then I would go up 5. Okay, 1, 2, 3, 4, 5. And that would be my point. So over 3, and then up 5. Because that's what the x and the y in a coordinate point tell you to do. So if I'm doing an equation like this, and I start at the origin, and I'm going to a point x, y, that's going to be a little bit different. Think about it like this. If I wanted to plot the point x, y, that means I need to go over 1, 2, 3, 4, I don't know, x. So I would go over x units, and x could be anything. So it's not actually 1, 2, 3, 4, 5, 6, 7. It's not 7. X is not 7. X is just representative of any number. So I went over x. Now how many do I go up? I go up like 1, 2, 3, 4, 5, 6, 7, 8, whatever. I go up to y. So this is up y units. Because remember, we went over x and we went up y. So if I'm looking at this example over here, I start from the origin and I want to plot this point. Think of it like this. I go over x units, just scribbling to show my motion. And how many units do I go up? I go up y units. Okay, so this line, the orange line, would be y. But wait, I need the equation of the blue line, because that's the line from the point to the directrix. The blue line is shorter. So it's not going to be over and up y. It's not going to be up y, because y would be too long. So the blue line is shorter by how many units? This space in here is 1. Right? Because that's the line, y equals 1. So this line is not going to be y, it's shorter. Shorter by how much? Shorter by 1. Okay, so I'll finish this question. I'll do it quick. You can slow down the speed if you have any issues or you feel like I'm going too fast. I'm going to set up the distance formula, x2 minus x1 squared plus y2 minus y1 squared, and that's going to be equal to, boom, y minus 1. I need to decide which point is going to be which, and it doesn't matter. So let's say point 1 is x comma y, and let's say that point 2 is the focus point, which is 0, 5. I'm going to plug these in. Point 2, so this is going to be x2, and this is going to be y2. This is going to be x1, and this is going to be y1. I just pulled them from here. It's the first point, so it's x1 and y1. I want to give myself a little breathing room because I'm getting a little too close here with these. But essentially I'm going to rewrite the equation with those substituted in. So parentheses, put back your minus signs, your plus signs, your squares. And that's all still equal to y minus 1. The one thing that I notice about this, and since I can digitally erase, I'll go ahead and do so, is that 0 minus x is just negative x. So that's kind of cool. What I notice now about this equation is I'd really like to expand it and get rid of that square root. I don't like square roots. Square roots are messy. I want to get rid of it. How do I get rid of a square root? With a square. If I square one side, I need to square the other though. Now cross out the square root, because the square and the square root cancel each other out. When I rewrite, I have negative x squared plus 5 minus y squared is equal to y minus 1 squared. Now for both of these, if you're comfortable with it, you can do the box method. 5 minus y times 5 minus y, and y minus 1 times y minus 1. Me, since I'm an old pro at this, I'm going to use the shortcut for squaring binomials. Let's clean this guy up here on the left. Negative x times negative x is positive x squared. And let's handle the 5 minus y squared. What we do is we square this. 5 squared is positive 25. Then we square this. Negative y times negative y is positive y squared. Now look at the product of these two. What's 5 times negative y? That's negative 5y, right? Times that by 2, and that becomes our middle term. If you can get the hang of that, it makes squaring these easier, but you would get the same exact result as if you used a box method. So you don't have to feel pressured to use a shortcut. You can use the box method on the sidebar. On the right-hand side, I'll do the same shortcut. Y squared, oh, well, that's y squared. That's easy. Negative 1 squared. Negative 1 times negative 1 is positive 1. These two multiplied together, negative 1y times 2 is negative 2y. Now here's the best part, the y squared's on both sides. If I subtract one off trying to move it, instead I end up canceling them out. That's great. Makes my life very easy. So I've got x squared plus 25 minus 10y equals negative 2y plus 1. Remember that I'm trying to solve for an equation. So our goal at this point is just to get y by itself. So here's what I want to do. I want to move this y over, and I want to get this 1 out of here, so that I can just have the y's. So here's how I'm going to do that. I'm going to add 10y to cancel this. That means I have to add 10y here. I don't really want this 1 here, so I'm going to subtract it off. And it'll get subtracted from the 25. So I get x squared plus 24 is equal to 8y. Last step. Get y by itself, you have to divide by 8, but it means you have to divide everything by 8. So I get 1/8 x squared plus 3 is equal to y. And that's the equation of the parabola that we were looking for. Now I'll show you a way to make these a little bit easier on yourself. Think about it like this. If I had one of these scenarios where I have the axes, and then I have my focus point, and I have my directrix, and that means that I have somewhere in between, I have a parabola. We talk about this vertical distance here as related to the parabola and the directrix. Now this is a shorter line, right? This is shorter than it would otherwise be if I drew it from here to the y-axis. This is shorter. So there's going to be a y minus some number because it's shorter, right? Shorter, it becomes shorter through subtraction. So if I moved the directrix this line right here would then have to be longer than it would otherwise be if it just went to the y-axis. So here's the idea. If the focus point and directrix are on the opposite side, that means they are further. Right? They're further away. That makes sense, opposite side, so they're further away. That means the distance is larger, meaning that our right side of our equation with whatever underneath is going to be equal to y plus something. What is that something? It's the number from the directrix. Now, if we have the same side of the x-axis, that means they must be closer. That means that the distance is smaller and our formula looks like this. Square root of distance formula equals y minus the number from the directrix. And these directrix numbers should both be thought of as being in absolute values. We're talking about distance. We're not talking about displacement or direction. So I'm only concerned with what's the number on the directrix. These are some great notes to make it so that you don't have to draw graphs anymore. I'm going to walk you through a couple examples on the back of the sheet just to show you how you would start them based on these rules here. Okay, question 14. Derive the analytic equation of a parabola given a focus of 0, 3 and a directrix of y equals 1. Think about it. If I had a graph, 0, 3 would be up here. Okay, so this is a positive y. This y equals 1 is also a positive y. So since they're both positive, the y values since they're the same sign, that means they're on the same side. And they are closer together. That logical connection makes sense. They're both above the x-axis. They're the same sign, so that means that they're closer. They're on the same side. They would both be up here, right? And since they're closer together, my distance formula, which is set up the same way, is going to be equal to y minus 1. You would set up the distance formula the same way, right, with 2 points, with the focus point and the point xy. You would still set that up the same way. I'll do a couple of these and then I'll show you exactly what I mean. Let's look at the next question, which is question number 15. We have a focus of 0, negative 3, and a directrix of y equals 3. So this negative 3 means that it is below the x-axis, and this is above. So that means below, and this is above the x-axis. So let's think. They're opposite sides. That means that they're a greater distance apart. Means that our equation with the distance formula is going to be equal to y plus something. Because it's got to be greater. Plus what? Plus 3. So you can solve that, set up the equation without actually doing an example question. Next one, 6 and 2. Same side, so they're closer together. So I'm going to get y minus 2 on the right side of my equal sign. Next one, 4 and 4. Same side. So they're closer. And that means my distance is shorter. So that means we're looking at y minus 4. Because how do you make something shorter or smaller? But by subtracting from it. So that's what the other side of the equation would be. The last one that I want to cover is question number 18, because I want to cover this whole double negative thing. This is negative, so it's below. This is negative, so it's below. So they're closer because they're on the same side. Since they're closer, that means I have y minus something. Y minus what? I would set up the equation equal to y minus 2. Now, if you want to see the actual setup, I'll show you the setup for question number 18. They said that my point is -4, -6, and I have a directrix of y equals -2. So I say, okay, let's let point 1 be -4, -6, and we can let point 2 be x comma y. I already know what this side is going to be. I said it's going to be y minus 2, minus because they're closer together because they're on the same side. I'll set the equation like this: x2 minus x1 squared plus y2 minus y1 squared is equal to y minus 2. Plug in on the left hand side with these points. So this would be minus -4. It's a little fun, double negative. And here would be minus -6. These guys will get plugged in as x and y. Bring down the rest of the equation. You can turn these double negatives into plus signs. Didn't mean to erase the 4. Change those into pluses. And they're still equal to y minus 2. Now look, I can solve this as is. Square both sides, do some box methods or some shortcuts on these, and I will get the right answer without ever drawing a graph. So if you get that, awesome. If not, you can feel free to catch me during the day or in office hours. See you guys tomorrow.